Lecture 5 Logical Database Design and Relationship Model. So, under this lecture, this is our lecture 5. Actually, we have to discuss what is the logical database design and how to derive a logical model from the information represented in ER model, conceptual model, and we focus on one type of logical model, that is the relational model. When you get the steps in database design and implementation, first of all, we have to understand the business problem and study and analyze. So we have to get the requirement. So we had by discussing for the client, with the client, we can get the requirement of the client. Then we design a conceptual model. By interviewing and integrate, we could get the requirement, and we design a conceptual model. Then the conceptual model, that is ER, using the entities and the relationships. Each entity may have a set of attributes, and after that we must transform this conceptual model to the logical model relations. So from this lecture, I am going to explain how to transform the conceptual model to the logical model, and after transforming that one, we have to refine that using the normalization, schema refinement. Then after refinement, we can implement the data tables. Okay, relational model, actually, you know that now you know the history of the database, how to develop the databases from the hierarchical model, network model, then relational model, and object-oriented, object-relational. Likewise, there may have some different data models, but the most commonly used as well as the famous model is relational model, because it is very easy to understand and also can modify it very easily without any effort, so that the data model on which most database management systems implements are based on the COD model introduced in 1970s. The simple and elegant mode, as well as everything, is a relation. Relation is actually a table. Each table may have the attributes. When you get the entities can be converted to the table. Then entity has a set of attributes. Attributes are the columns of the table. And if you want to store the data of a certain entity, the row, normally we call the tuple. Tuples represent the data of a certain entity. For an example, if you get the here you can see this picture also. So if you get the one entity as student has the student name, date of birth, telephone number, permanent address, university degree program, likewise. Then those are the attributes. And also, when you store information about the data, the Rohan, age as well as address, those information of one student is called the tuple. The row indicates the information of the student. So then very easy to handle those tables. There are standard way to convert from the ER model to the conceptual model. ER model, that is ER model, relational model, to the conceptual model means the logical model. From this ER model that you have drawn from the ER diagrams using the notations. You have to convert it to the,
Excuse me, sir.
yes,
Can't see your screen. Could you please share it?
I have shared the screen. I don't know why. Now it's okay. Can you see?
Yes, sir.
Okay, then you can see this ER model to the conceptual model like the tables and tables. So, tables. So the ER model, that relational model, to be converted to the conceptual model. Actually, this is called the conceptual model. When you consider relational model, called the logical model. So you can indicate in this table what are the primary keys and how to connect these tables each other. Okay, the relational model represents the database as a collection of relations. Relation consists of the relation schema and the relation instances. So the relation is something like that. You can call the relation name, that is the entity name, and these, the blue color one, are the attributes. Those are the attributes of this attributes: name, student number, home phone address, office phone, age, GPA, like this. These, the rows of the table represent the information about student. This is called the tuples. So you have to understand these keywords very clearly. Columns represent the attributes of the table, relation name is there, and also the tuples. And you can show the primary key. If SSN is the primary key, you can underline the name of that primary key. So this is called the schema. Here, that part is called the schema. Then instance, the schema and instance. Schema and instance. Schema and instance. So let's see the relation schema. The schema describes the column heads, that is attribute of a relation, name of the relation, name of each field, that is attribute, domain of each field, as well as domain is described by the domain name and the set associated values. Domain name and the associated values. When you have to do the practicals for this one. For an example, GPA, you can set the domain value. GPA maximum is the 4, minimum is 0. If someone is going to enter the more than 4, then it will be given the error message, that is the out of the domain range. Likewise, you can set the domain name, and also you can when you are designing the table, you can set the default values. You can set the default values for that one. For an example, address. If you want to see always Colombo, you can see the Colombo, and if someone want to change, that can be changed. Likewise, default values also can be set, as well as domain value. Age, consider the age. Can someone has the age 500 years or 400 years? No, that is completely wrong. Then age also 0 to 100 or 120. Maximum 100, very, very rare. Hardly we can find the 120 age student, so that you can set as a 80 or 70. Likewise, okay, if you are going to enter the more than that value, you will be given a error message. That is the main advantage you have when you are going to define the schema and set the domain values. Relation schema name, relation name, and student is a name, and also here you have to give the data type of this one. SID is a type is string, name also string, logging also string, age integer, and you can set the value. GPA is the real because the decimal points also you will have to write with that. And these are the field names, is the attribute names. So these are the domains, and also when you are going to enter the values for these each fields, you have to enter the right data type, otherwise you will be given error message. For the SID, if you are going to enter the integer number, sometimes you may have some. For a name, you are going to enter the numbers, numerical values, you will be given an error message because the data type is wrong. Domain GPA, the real, you can put the value domain value 0 to 4. Likewise, then if someone is going to enter more than 4 while entering the data, then he will be given an error message. Set of tuples or records or rows, relation instances. These are the instances. Each instances is the row. Row indicates the information about the student here in this example. So set of tuples or records. Set of tuples or records. And each tuple has a name. Each tuple has the same number of fields as the relation schema. Each tuple has a same number of fields as a relation schema. Or this is called the relation instance. So another one is sometimes there may have some attributes or the attributes that may not have value. For an example, here you can see the phone number. Sometimes some students may have phone numbers and some students may not have phone numbers. In such case, you can put as the null. Also allow to enter the null values also. Sometimes get the name. If all the student must have a name, otherwise these fields may not have the null values. Office phone also may have the null values, so that you can clearly understand which fields, which attributes may have null values and which attributes may not have null values. Degree of relation. Degree of a relation, normally degree of R indicates the relation is the number of attributes in R. Number of attributes, that is number of columns in R. ID, name, address and phone. These are the columns of the table. That degree is 4. R is 4. Here ID, name, address and phone number. Degree of this relation is 4. There are 4 attributes and 4 columns to represent each attribute. Do this example. Make a list of students in the class, keeping their IDs, names and phone number. Okay. One example. And this is the basic structure of the relational model, table or the relation. This is the basic structure. the relation must have a relation name and also the attribute list. Number of attributes represent the previously I explained the degree of a relation, and also tuples represent the instance of the relation. So formalizing once again these relations, when we define this relation, a relation is the name table of data. A relation we can define as a relation is a name table of data. Get the student or the employee. Employee is the relation name, and each whether it is student or employee may have the employee. If it is employee name, employee number, department, date of birth. Likewise, those are the attributes in a relation. So table is made up of rows, records or tuples, and columns, attributes or fields. The columns called the attributes. Actually, columns represent the attributes. Rows represent the data of that. If it is a student information, a particular student information. Not all table qualify as relations. They may have a requirements. Every relation has a unique name. When you get the database, you can find the unique names of the relations. No two names are used for two, same name are used for the two tables. So every relation has a unique name. Every attribute value is atomic. Every attribute has atomic value. What is this atomic? Not multi-valued or not composite. So get the name. Name has the first name, middle name, and surname. And you can have a separate relation to indicate that one. So each must have an atomic value, that is not the multi-valued or not the composite one. And also relation name is a unique name. These are the characteristics of and also the requirement of the relation. Every row is unique. Every row is unique. Can't have two rows with the same value for all their fields. So sometimes there may have some same names, same birthdays, but some of the attributes must different. So sometimes you get that student there is a one pair, that is twins. Get the twins, they have the same address, same telephone, same address, same home number, and sometimes same department, same faculty, but the name must be different, so that at least one attribute must be different in the relation. And so attributes, columns in a table have unique names. The attributes also must have unique names. So the order of the columns is irrelevant. The order of the rows is irrelevant. So that is not relevant. Actually, sometimes there may have some this one department. When you consider the department IDs also may have some similar names, but when you access that one, you have to access department.did. So you can differentiate from that one the relation name. When we practice this one, you will be able to understand these things clearly. Then primary key fields, minimal set of attributes. We discussed the last week also about the primary key. The minimal set of attributes that uniquely identify the row. This is how we can guarantee that all rows are unique. So can someone explain what is a super key? What is a super key? So don't worry about it. If you make a mistake, no one is going to laugh at you. And the primary key, the primary key that can represent all the attributes of the relation, as well as it must have the minimal set of attributes. That is, minimal set is only most probably one. So what is a super key? What is a candidate key? What are the candidate keys and what are the super keys? So last week I explained. So when you come to the class, please go through the previous lesson. Then, because always today's lesson has a connection with the previous lesson. So you have to have a understanding about the different types of keys. The primary key I explained now, and super key and candidate keys, all you have to understand. Foreign key is a set of attributes in a table that serves as the reference to the primary key to the another table. Primary and foreign key connection is there when you want to retrieve the data from the tables. Okay. Foreign key, the constraint involving two relations, referencing relation and referenced relation. Referencing relation and reference relation. Tuples in a referencing relations. Tuples in a referencing relation get the table that have some instance called the tuples. Referencing relation have attributes, foreign keys, FK, called the foreign key attributes, that reference the primary key attributes, PK, of the reference relation. Referencing is in the enrolled one, CID, grade, then student. Reference is student, name, login, age, and GPA, referenced. So when you get the enrolled, this is actually this will be the foreign, and this will be the primary key. If someone wants to get the students who are enrolled in this course, then you can use these two keys. So student ID is the foreign key of this one, and SID is the primary key of this student. The enroll also has the CID is the primary key, grade, and here this always you can see the SID and student ID is same. SID and student ID. This will be the foreign key and this will be the primary key. And if someone want to get the information about enroll, then you can use this primary key, so that each relation may have the foreign key and primary key both, the FK, and this is called the PK, primary key. So display the foreign keys by drawing an arrow from the foreign key to the primary key. Always when you want to write the relation, you can write foreign key to primary key, foreign key to primary key. Integrity constraint. Integrity constraint, normally called the IC, database management system must prevent entry from the incorrect information. And to prevent the constraint conditions are specified on the relational schema. That's why I told you can set the values. Earlier I explained two examples. GPA must have 0 to 4. You can't find the value exceeding 4. And also the age 0 to 100. No one if someone is going to enter the age as 150, it will be given an error message. So database which satisfies all the constraints specified on the database schema is a legal instance, so that when you enter the data data to the tables, all those values must have the legal data. That's why we are going to use this integrity constraints. So database management system enforces constraint permits only legal instance to be stored. That permits only legal data to enter to the table. So when the application is run, database management system checks for the violation and disallow the changes to the data that violates the specified integrity constraint. So that's why you will be given the error message if you are violating these values. So this integrity constraint specifies and enforce at different times. And specified means when the database administrator or the end user defines the database schema, and also enforces when the database application is run. When the database application is run, it will enforced. The DBMS check for the violations and disallow the violation entries. So when the database administrator or the database designer must give the correct values for the attributes as domain values. So there are four integrity constraints: domain constraints, key constraint, entity integrity constraint, and referential integrity constraint. So when I am going to stop the class from this integrity constraint. I will continue from this and explain what are these integrity constraint: domain constraint, key constraint, entity integrity constraint, and the referential integrity constraint in the next class.